Good morning, everyone. Bonjour. I apologize because I don't speak French, so I can talk in English. First of all, I would like to thank the organizer for giving me this opportunity to stay here and to share with you our technologies, our studies in precision viticulture. Thank you, Peter, for special for this opportunity. So maybe okay. Thank you. Yeah. So my name is Javier Tardaguila. I am professor of viticulture, precision viticulture at the University of La Rioja in the north of Spain, and also I am researcher of the ICVB in Logroño. And also I am the director of the Televitis group. Our team is focused on precision viticulture. We have we started 10 years ago when I came back from Australia. I learned a lot of things in Australia about the precision viticulture. And we just focus on non-invasive, not destructive tools for viticulture. We try to develop and apply different technologies for assessing the vineyard and also for phenotyping. We think that in many cases the main decision in viticulture are based in visual inspection. So we think that we need more data, we need more information in order to improve the decision making. And I think we have to replace many adjectives for the data. That is in the future. And we are focused on different topics and in different parameters. Mainly we are developing new on-the-go tools for measuring, for assessing plant water status, and also for grape composition. And also we are very interested to develop new tool for yield components assessment. And 2 years ago, we developed one of the first app in viticulture for assessing the number of flowers per inflorescence in the field. That's the called Vitis Flower. Is free available in Google. In order to improve the real application on these tools and this technology, we try to develop we call Televitis Mobile Lab. The idea is to mount different sensor on the quad in the ATV in order to measure different key parameters. For example, pruning weight, canopy status, exposed and cluster leaves. And also, for example, we are working now very hard on yield components and plant water status. All the data are georeferences, so we are able to map all this information. This is the idea, and we are working very hard. And also, we work on the go at 5 kilometers per hour. So this is, I think, is one good tool for real application and the industrial level in precision viticulture. And also we are also involved in robotics. I am the coordinator of the Divine Robot project, and after lunch I can talk about that. Well, regarding my talk, regarding the hyperspectral imaging, this is one of them, I think one of the most powerful tool for phenotyping, for assessing different parameters as not destructive way. So if we compare the RGB, the color image, with the hyperspectral image, in the color image we have, for each pixel we have 3 bands, R, G, B, but in the hyperspectral image, for each pixel we have 100 or 1,000 of bands. So we have a lot of information. So in working on hyperspectral imaging, we work on computer vision and also in spectroscopy. And Laura and Thoran talk about this spectroscopy is very useful. So the idea is that the spectrum, the spectrum, and we can obtain for each pixel represents or is linked to the properties of the each tissue. So if we compare the hyperspectral imaging with the multispectral imaging, in the multispectral imaging we have several bands, maybe 2, 3, 4, 6. But in the hyperspectral imaging we have 100 or 1,000. So we talk not the image, we have talked about the cube of the information. And there are different technologies for image acquisition. The most common technology is scanning, so or also we call push-broom method. The idea is just we can get one line and by scanning moving the target or moving the camera, we can obtain the area, okay? And there are another method, they call snapshot. The idea is that one shot we can get the whole image. But both systems, both technologies, they have different pros and cons. And here you have our camera. We use two cameras, two hyperspectral cameras in our lab. One indivisible between 400 and 1,000 nanometers. So you can see here for each pixel we can get 1,200 bands. So a lot of information. And from the near infrared with the low resolution we have about 265 bands. So we linked both cameras with a mirror scanner in order to get for one line to get an image. We can work with both cameras, but also we can work with separate cameras in our lab. And also we are able to work with this camera in the field. This is a big challenge, just moving from the lab to the field. But we just started several years ago, and we have to work harder in this way. Well, the hyperspectral imaging is very a powerful tool and apply in different application: agriculture, forestry, environment, medicine, water quality, food quality, and safety control, geology, and also even in medicine. We can work with in the lab, we can work with the proximal sensing, and also there are many applications using hyperspectral imaging and remote sensing, using planes and now maybe drones. Regarding the application in viticulture, I would like to start with this nice sample published last year for the colleague from Germany. Ork and Toffer and other colleague, and they demonstrated that the hyperspectral imaging is very useful tool for phenotyping the incidence and the reaction on the downy mildew. That is one of the most important diseases in viticulture. This is one very nice sample published last year for the German colleagues. And I can go with our experience in my lab, in Televitis lab. And first of all, we focus on if we can separate, we can discriminate different plant water status. And here you can see one sample, and we separated two different plant water status from the 95 relative water content and 75 relative water content. This is one example that we can get information about the leaf water status using hyperspectral camera in the lab. Very simple approach. And also we observe that there's some small differences in the spectrum of the different varieties. So we went further. So with some colleague in the Douro in Portugal, we try to study if with if we can discriminate, we can separate the different clones and different varieties using the hyperspectral camera. So we perform a big experiment with the hyperspectral camera in the visible and the NAR range. And we use different data mining techniques for pre-processing and processing the data. And here you have we use 3 varieties, Grenache, Tempranillo, and Cabernet Sauvignon, and different clones. So the question is that, can we separate, can we discriminate this variety using the hyperspectral imaging? And here you can see one example. You can see on the left the spectra. There are some differences, and here we have the result, the final result. So we obtained that in all cases more than 90% of the total samples were correctly classified. So it is an alternative method to PCR, another genotyping method to classify, discriminate the varieties. But we went further, and also we show that we can separate the clones for each different variety. So this is very difficult, even with the PCR techniques. And in this case, more than 80% of the clone were correctly classified. So this is very important, because now in many cases when the wine industry buy or viticulture buy any clone, is blind. Nobody knows what real clone is. So this is one technique, and this is one example. One example that the powerful of this very, very fine technology. And finally, I would like to also to explain the last work using hyperspectral imaging. This is work published last year in our team, also in collaboration with the Portuguese team in the Douro Valley from the TAT University. And the idea is that can we develop an alternative method for measuring, for fingerprint the anthocyanin compounds using the hyperspectral imaging? And also the idea is that our question is, from this spectra, can we get the concentration of the total and each single anthocyanin compounds? Is this possible? Well, this is we try to explore. We try to explore and to develop a rapid and alternative method to HPLC. That's the classical method for measuring the ant compound content in the grapes. So we did several measurements in the intact berries. We use 8 varieties, 10 berries per variety, and 4 berries each. For example, we work with the hyperspectral camera in the visible range, and we obtain different spectra. And here you can see the correlation, and this is it also was published by other colleagues. And this is we demonstrated that the predicted, we built the different models, and our prediction for the total anthocyanin was correlated, very good correlating with the measurement by HPLC for the total and for the glycoside anthocyanin. Here you have the coefficient of determination of the prediction is larger than 0.65. But we go further, and here we have a table. It is published, this paper, and we demonstrated that with this, the powerful tool, we can separate and we can evaluate the concentration of each single compound, for 14 compounds. Here you have the calibration, that's very important. The calibration, the cross-validation. The cross-validation is moved from 0.7 to 0.93, and also the external validation. This is very important. It's one example of the powerful of this technique to fingerprint the anthocyanin content. And just before finish, just I would like to give you another line that we are just trying to explore. And you know that the ESCA disease is one of the biggest problem in the world, also in Spain, in the world. So we try to explore if with this technique we can phenotype and we can assess the incidence of the trunk diseases in the vine. So we just started last year, and we will see. And just for the conclusion, that is in my opinion and in our experience, this is the hyperspectral imaging is one of the most powerful tools for vineyard monitoring and for phenotyping. We can use under indoor or outdoor condition, and also we can work by proximal or remote application, and we can obtain different parameters, key parameters for each single spectrum. And that's it. You have here our team, our website. You can get our work, our publication, and you can see our email. Of course, we are very open to any collaboration with any of you, and we are very happy to stay here and to share with you our experience. Thank you very much.